Welcome to the Crazy Head Chemist. Here we go. Equilibrium and reactions rates. Bam! The solubility product constant. That is the KSP. So KSP is the solubility product constant. Notice that the word solubility product is the KSP in the KSP. Okay? So the equilibrium constant of a slightly soluble salt following our solubility rules. That is solids. So one time you memorized your solubility rules. So they're either aqueous or they're solid. We are just talking about the things that are solids. So we told you that it was either black or white. It was either aqueous or it was solid. Now we're going to find out that those solids on the solubility rules are actually an equilibrium reaction and they are slightly soluble. That means they do break apart into going to their ions. Okay, aluminum hydroxide is one of those insoluble precipitates because hydroxides are insoluble except for ammonium ion and group 1 ions. So what we're going to do is we're going to take this aluminum hydroxide, that is a solid, and break it apart into its constituent ions of a cation and an anion, and we're going to balance it at the same time. And they are soluble slightly, so therefore it's aqueous. So therefore we have an aluminum ion with a 3+ charge and a hydroxide ion with a 1- charge. Notice that there's 3 hydroxides to balance out the mass of the hydroxides. This equation is actually balanced for mass and charge. Notice that on the reactant side there's a net charge of 0, and on the product side there's actually a net charge of 0 as well. That's the 3+ on the aluminum and 3 times -1 for the hydroxide. The 3+ and the 3-, that adds up to a 0. There's 1 aluminum on the reactant side, 1 aluminum on the product side, 3 oxygens on the reactant and product side, and 3 hydrogens on the reactant and product side. Notice that equilibrium arrows are a little bit different here. That large arrow is facing towards the reactant side, which is a solid. Okay? So now what we're going to do is we're going to write the KEQ expression, but because it's so special, it's a solid. Okay, therefore we're going to write a KSP expression, but the math and the equation is the same, and that is products over reactants with the stoichiometric coefficients as exponents. I hope you heard me say that before. Products over reactants with the stoichiometric coefficients as exponents. What are not included in any K expression? Solids and liquids. Do you see a solid in this? Absolutely. And that's what makes KSP expressions so special, SP for special, and that is that they always start off with a solid on the reactant side. The products are always 2 ions, 1 cation, 1 anion, and they are always aqueous. So we're going to write the KSP expression. Products of reactants, stoichiometric coefficients as exponents, and there it is. Hopefully you see that 3 as that exponent on the hydroxide. There is no denominator. There is never a denominator on a KSP expression because the reactant is a solid. That's why they're not included in KSP expressions. So now we're going to ask ourselves, what is the mole ratio between the aluminum and the hydroxide? The aluminum has a stoichiometric coefficient of a 1. And the stoichiometric coefficient on the hydroxide is a 3. So now what we're going to do is we're going to substitute in for the aluminum the 1x, substitute in for the hydroxide the 3x into that KSP expression. And we're going to get the following. Okay, that KSP is equal to 1x times 3x with the quantity of that cubed up there at the top. Okay, that's going to play a very important role later on. So we're going to draw what you would see in a test tube of aluminum hydroxide solid if you put it in water. So what would you see? You would see something like this. A bunch of liquid water and a lot of solid. Aluminum hydroxide is a white precipitate, and there are very few ions of aluminum ion and hydroxide ions inside that solution of water. Okay? Hopefully that works out for you. Practice that one again. And let me see if I get this hat on. That was the 13th video, solubility product constant. Give me a thumbs up.